Going to go over any review questions you have for tonight. Area between curves, disc washer shell, arc length, surface area. I'm going to email the test out to everybody tomorrow, sometime around the middle of the day. I don't have an exact time yet, so I'll be emailing that to you. I'm not going to put it on Canvas. You're just going to get an email. You will have one whole day to do it, so you have 24 hours to get it back to me. So if I send it to you at, I don't know, noon, you'll have till noon on Thursday to get it back to me. If I send it to you at 2 o'clock in the afternoon, you'll have till 2 o'clock in the afternoon on Thursday to get it back to me. All the instructions for how you're going to hand it in, which is basically either take a photograph or scan it, and then you're going to email it to me. You're not going to put it up on Canvas. You're not going to put it in Dropbox. You're just going to send me directly an email. And all of that information is written on the test paper itself, right up at the top. Questions are, I'm not treating this any differently than if we were sitting in a classroom. You know, it's not going to be like twice as many questions as I ask or anything like that. It's just going to be a normal, regular Calc 2 test that you would have an hour, you would have like 2 hours to do, but you have 24 hours to do it. All right. So what are we going to do tonight? What would you like to see? Review questions from the review sheet, from old homework, from anything you want. What do you got?
I have a question from the review sheet.
Okay. Which one? Which one, Michaela?
Number 3.
Number 3, and one of the Kyles, I see number 1. There's 2 Kyles in here, so I don't know which one that is, but there's 2 of you. So we'll do number 3, and then we'll do number 1. All right, so number 3. All right, so number 3. All right, so question number 3. We have this picture. That graph is the square root of sine of x. And it says to use the disk method from 0 to pi. So that shape is going around the x-axis. So it's not going to make a sphere, but it's going to make like a round sort of rugby football shape to it on here. And it specifies disk method. So since we're using disk, our rectangles look like that. They spin around, make a disk. We're working dx because the rectangle is vertical. And all we have is a radius. So in this case, the radius is from the x-axis to the function. So the function is the radius on this problem. And we go right to, so anytime you spin things around, something has to be squared. The only time you don't square anything is if we're looking at area between a curve, that's flat. The shell method, nothing gets squared, and arc length and surface area. So this integral will be pi from 0 to pi. And it will be the square root of the sine of x squared dx. So that's the integral we have to do. So if everybody's okay on that. So I'm going to erase this part because I need some room. Well, you square a square root, it just kind of like goes away. And so our integral becomes 0 to pi sine of x dx. And the integral of sine is cosine, but is it positive or negative?
It'd be negative.
That's right. The integral of positive sine is negative cosine. So we end up with negative pi cosine of x from 0 to pi. So that takes us through the calculus part. Next step is to plug in the numbers. Top goes in first. So we get negative pi cosine of pi minus negative pi cosine of 0. So here's a case where 0 doesn't give us 0. The cosine of pi is, what's the cosine of pi? Think unit circle.
-1.
Cosine of pi is -1. This makes it +1. Cosine of 0 is +1, and negative is positive. And so we, and these pi's are here. So our answer is 2 pi. And the units would be units cubed on there. So is that okay, Michaela?
Yeah, I forgot to square like the square root sign next. So I was like wondering if I knew how to solve that integral.
Oh, so you're thinking just integrating the square root of sine?
Yeah.
Yeah, no, that's actually a very hard problem, by the way.
Yeah, I was like, how do I do this?
Yeah. Also, so integrating the square root of sine is difficult. Integrating sine squared is something that we'll be doing in chapter 8. That one's not so bad. So that was a good question to ask. So you're good now?
Yes, thank you.
Anytime that something spins around, you're getting a circular motion, so something will always be squared.
Got it. Thank you.
Okay. And then one of the Kyles, you want to see number 1, all right? So number 1. All right, so number 1 is just area. Nothing's moving on this one. So number 1 is only area. And you've got this picture. You got a down parabola and you got an up parabola. And tomorrow when I send out the test, some of the problems will have the picture with them and some of them won't. You kind of have to figure that out on your own. But you've all got ways to do graphing. So here's the shape that we're doing right there. And we're just doing area. Okay. Now, so the first step is we have to know the x values that we're going from and to, and that's where these two functions come together. So before we even get to all of that, we have to set those two functions together. So we have to take the f function and set it equal to the g function. So that gives us x squared minus 1. At these 2 points, that function will equal 7 minus x squared. So we're trying to find the points of intersection here because we need those 2 numbers. All right, a little bit of algebra. I'm going to bring the negative x squared over to this side and the negative 1 over there. And that gives us 2x squared is equal to 8. That says that x squared is equal to 4. So now we know the square root of x squared is 4. So we're going from -2 to 2. Those are our x values. All right, questions yet? I think there's one other problem on here that you have to like figure out the intercepts as well. Okay, so now we're ready to go. Now we can make this problem easier. Whoops, hold on, waiting for somebody else to pop in here. There we go. Hi, Chenille, can you hear me and all that? Oh, there you are. So you can hear me now? Okay. So we have a choice here. We can integrate from -2 to 2, or we can take advantage of symmetry. This side is equal to that side. Well, not on my drawing, but on the graph on your paper. So it's probably going to be easier to do 0 to 2 and just multiply by 2. So I'm going to do that. Although you can do -2 to 2, you'll still get the same answer. There'll just be more arithmetic to do. Okay, so we're ready to set up the equation. So we're going to integrate. I'm going to cut it in half and do 0 to 2, and then I have to multiply it. So the next step is to do area. It's top minus bottom. Which of those two functions is the top? Which function is the top function? This one.
7 minus x squared.
I couldn't hear what that's, what'd you say?
7 minus x squared.
Yep, the top function is the downward opening parabola. So this is the g function, and the f function is upward opening, so that's the bottom function. So we're going to do 7 minus x squared minus x squared plus 1. So we are doing g minus f, top minus bottom. And I distributed this negative sign all the way through, so the f of x became negative x squared and positive 1. Stop there if anybody's got a question. We can integrate that just like it is, but we can make it a little bit easier by combining stuff. So we get negative 2x squared plus 8. That's a little, all I did was add those up together. So that's a little bit easier. And now we just integrate. The integral of negative 2x squared is negative 2/3 x cubed. The integral of positive 8 is positive 8x. And we are going from 0 to 2. Now, if you had gone from negative 2 to 2, you wouldn't have this here. You'd have a negative 2 down here, and you have more work to do. So using symmetry was a lazier way to do it. We put 2 in here. 2 cubed is 8. So that gives me negative 16 over 3. We put a 2 here, and we get 16. We put 0 in here, and we get 0. And essentially, that's the answer. You just have a little bit of arithmetic to do over there. So the arithmetic that we would do there would be, I'm going to go up here. So we get 2 times negative 16 over 3 plus 3, 4, 30, 54 over 3. 16 times 3, 54. Did I do that right? Yeah, I did. So we get 2 times, let's see here. So
16 times 3 is 48. No?
38 over 3, I think. So 60.
16 times 3, 48.
So I think it's 76 over 3. I might have done the arithmetic wrong in my head.
16 times 3 is 48.
48. You know, I knew that, and for some reason, I don't know why I did that. Thank you. It's amazing I have this job, isn't it? So that'd be 32. So the final answer would be 64 over 3, unless I screwed something else again. All right. So that was for one of the Kyles. Kyle, you okay with that?
Can I ask a question?
Sure. Go ahead, Jordan.
Yeah. Why did you set the functions equal to each other? Like, I get that they are, their area is,
Right.
but we didn't use it within our integral.
Oh, that was the limits, the 0 and the 2. So if you have 2 functions, so here's a function and here's a function. If I want to do this area right here, I have to know where they come together in order to set where I'm integrating from and to. And so the way to come up with these values, at these 2 points, those functions are both at the same place. So at that point, they equal each other. And that's how you find the boundaries of that region.
Okay, so when you take the square root of each side, you get plus or minus.
That's correct.
Okay, yeah, because I just saw it was 2, but I wasn't. Gotcha.
Well, so what happened on the other problem? So on the other problem, when we set them equal together, this was -2 and that was +2, right? So we could have integrated from -2 to 2 and we would have gotten this answer if we did the arithmetic right. But because these two things are perfectly symmetric, I opted to integrate from 0 to 2. That will give me this area, and then I just doubled it to get the other side.
Yeah, I gotcha. Thank you.
Yep. So the other thing that you brought up, which I'll mention, I'm sure you all know, if someone asks you what's the square root of 81, the correct answer is 9, right? If someone says what's the square root of 81, you would say 9. But when that shows up into an equation, if you say x is equal to the square root of 81, then you need both of them, plus and minus 9, when you're in an equation. So just a little algebra thing on there. That's called the principal root. So that's what you use when you do square roots. Nicholas, yes, number 5, we can do that. As soon as I find it. Oh, it's got an E in it. Yeah, it's got an E in it. Okay. So number 5. There's our function, e to the -2x power. And the problem says we're going from 0 to 1. So the area that we're doing is that area right there. And we're going around the x-axis. So when that spins around, it's going to look sort of like a lampshade, I guess. I'm going to figure out how much water will that hold, or liquids or solids. All right. So this problem didn't specify a method. So it's up to you to figure out the method. So we have 3 methods for volume: disc, washer, and shell. Which ones can we use on this? Which ones can't we use on this? Which ones can we use? Which ones can't we use?
You can use this.
Oh, if you said something, Michaela, I couldn't hear it. Your volume is sort of down, I think.
You can use disc.
Yep, we can use disc. We can use disc. Can we use washer?
Yes.
Ah, can we?
Oh, maybe not.
You can't use washer because there's no empty space
yeah.
spinning around. No, but that's all right. The entire area is touching the x-axis, so there's no empty space. So washer is out. So disc. You can use shell, but shell would be very difficult. If we use shell, our rectangles would go this way, and we'd have to solve that equation for x. So we would get x is equal to the ln of y over -2, and that would get awful, but you could use shell. So we're going to use disc. All right, so here's our disc right here. That spins around. It's vertical, so it's dx. The x-axis is right here. Since it's disc, all we have is a radius. And the radius is the function. The top of that rectangle is touching the function everywhere. Then we go to set it up. Something's being squared because we're spinning around in a circle. So the integral becomes pi from 0 to 1 because the problem said that. And we have e to the negative 2x squared dx. That's the setup for the integral. Pause there if we got any questions. Whoops. Hold on, somebody fell out and they're coming back in. Hang on a minute. All right, Yakov, you back with us? Looked like you dropped out there for a second. All right. All right, so we do this integral. We have pi 0 to 1, and we have e to the negative 4x dx. When you square that, you get e to the negative 4x. Now we integrate. The integral of e to the negative 4x is negative 1/4 e to the negative 4x. Whoops. Then we're going from 0 to 1. Questions on that part? So here's another case when we put in 0, we don't get 0. So our final answer will be, if we put 1 in here, we get negative 1/4 e to the minus 4. Then we get minus negative 1/4 e to the 0. And that will give us pi times, that's pretty much the answer, negative 1/4 e to the negative 4 plus 1/4. And that's the answer. Just leave it like that. You could pull the 1/4 out, I guess, but it doesn't matter. That form of the answer is fine. I'm not all that concerned with what your answers look like. That's not really the point of what we're doing. So you can just leave them plain like that. All right. You're welcome, Nicholas. I hope that answered whatever the question was you had. Questions on that? What else we got for tonight? I'm just going to do whatever questions you want me to do. Anybody else got something? Doesn't even have to be from the review. It can be from, any of the other homeworks. So this review sheet is kind of what the test is going to look like, right? I mean, we haven't really, there'll be some like area questions. Some of the problems I will specify use disk or washer or shell. Some of the problems will be up to you to figure out what methods to use. Yeah, and that's kind of going to be it. Not a whole lot of problems. Doesn't need to be a whole lot of problems. You have plenty of time to work on them. So what else we got? Anything else? Be a short class if you don't ask me anything.
Can you do number 6, please?
You got it.
Thank you.
All right, number 6. So on Thursday, we'll be starting something new. Wouldn't it be nice to have a change? No more spinning things around. All right, number 6. So this problem, going around this, and it says to use the shell method. We're spinning a vertical line, and shell rhymes with parallel, so the rectangles here are vertical. And we're going around this line. All right. So shell method. We need 2 things. We need rho, and we need the height of the rectangle. If you spin the y-axis, rho is always x. If you spin not the y-axis, but another vertical line, rho will be 3 minus x. If this was a 7, it'd be 7 minus x. If this was a million, it'd be a million minus x. And the height of the rectangle is top minus bottom. The top of this region is parallel here, so the top is always 8 high. So the height is 8. Oh, geez, markers aren't working. And then we have to take away this empty space here. We got to take that away, and that's the function. And so we do minus x squared plus 4. That's the function. This dotted line is x squared plus 4 high. So we want the 8 and then take that away. So when I'm done doing this problem, I will show you why that's 3 minus x, by the way. So we need one other thing, and this goes back to that other problem. We need to know what that x value is where those functions come together. So we're going to be integrating from 0 to this number. So the function here is x squared plus 4. This dot is where x squared plus 4 equals 8. So x squared plus 4 equals 8 means x squared is equal to 4. So x is equal to plus or minus 2. But we only need this one over here. We only need that 2. So I hope you can see that all right. I can't tell if it looks right or not, but I don't think there's a glare on the board. All right, questions on that part yet? Now I'll explain this a little more in just a bit. All right, so now we go to the integral for shell. Shell is 2 pi. We're going from 0 to 2. And it's rho times h. So it's 3 minus x times 4 minus x squared dx. So we get 8 minus x squared, and then we get 8 minus 4, and that's where that 4 came from. I pulled that negative sign all the way through. Questions yet? Oh, so Chenille, the shell method is 2 pi. Shell method is always 2 pi. Disk and washer are pi. That's part of the formula. No, that's good. Glad you asked it. With arc length, there's no pi's at all. And with surface area, there's another 2 pi. Those are just part of the formula.
Okay, thank you.
You're welcome. All right, so to do this, we have to multiply out. Can't integrate it in that form. So we multiply everything out. So we get 12, 3 times 4, 3 times negative x squared, negative x times 4, and negative x times negative x squared. And there's our integral. Those are all different terms. They can't be combined. So we just have to integrate it right from there. Having trouble with markers tonight. So we integrate that. The integral of 12 with respect to x is 12x. The integral of negative 3x squared is negative x cubed. The integral of negative 4x is negative 2x squared. And the integral of negative x cubed is negative 1/4 x to the 4th. And we are going from 0 to 2. All that's left is to do the arithmetic, which is where I usually mess up. So we put 0 in here. These are all zeros, so I don't have to worry about that. So we put 2 in there. 12 times 2 is 24. 2 cubed is 8. 2 squared is 4 times negative 2 is negative 8. 2 to the 4th is 16. Divide by 4, that gives me negative 4. And so our whole answer becomes 16, negative 20. Negative 16, negative 20. So I think the answer is 8 pi, unless I made an arithmetic mistake. Totally possible. All right. Questions on that one? All right. What else we got?
Over the row. And
Yeah, that's right. I was going to do that. Thank you.
Yeah.
All right. If we're going to rotate a shape, let's say this shape. Let's say we're going to rotate this shape around this line. And I'm going to say that this line is x equals a number. So the equation x equals a number gives you a vertical line. If we were spinning around the y-axis, rho would just be x. Now here's what rho represents. Let me make this a little bit bigger. So this shape is going to go spinning around that line. So we're using shell method. Markers are, I think I got to clean the whiteboard. So here's what rho is. Here's a rectangle. That rectangle spins around and makes the shell, the tube. All right. Rho is the distance to the middle of that rectangle. That's where the formula comes from. So from the y-axis over to here, that's a distance of c. On the last problem, x was equal to 3. So from here to here would be 3. Now this distance right here, the distance from the y-axis, how far is it from the y-axis to any point on the x-axis? How far is it? How far from the y-axis to here, or here, or here, or here? Yes, it's x. This distance is x. What's left over? From here to here is x. So from here to here is the rest of it, which would be c minus x. So on the last problem, this was a 3, this was a 3, and this was a 3. So that's where the 3 minus x came from. So Chenille, that's, you got to do it the other way around. You have that backwards. To be c minus x. So this distance from here to here is 3. If this distance is 1, this distance is 2. Which would be 3 minus 1. So I think that was you, Jordan. Does that help?
Yes, thank you. I thought, for some reason, I don't know why, I thought you put the function down, so that makes a lot more sense now. You
So-
did for H, I kind of got them a little mixed up.
Right. So the shell questions on the test are all going to be vertical. They're all going to be dx, okay? If you spin the y-axis, rho is x. If you're spinning around another line, it's that number minus X. Those are the only two options for rho.
Gotcha. Thank you.
Yep, you're welcome. What else we got? Anything? So Nicholas, number 4. Yep. Number 4 coming up. All right, so number 4. So here's one where I didn't give the picture. But you all have graphing calculators, or you can look at that function and just know that it's a downward parabola. A little bit faster. So for number 4, y is equal to 4 minus x squared over 4. And then we're told y equals 2. And then we're told x equals 0. So that information, hold on, that information gives me a boundary. When x is 0, y is 4. So this is a parabola opening down. That's what the function looks like. X equals 0, that's the y-axis. So in this problem, I know I don't need this over here because I have the y-axis, the function, and the other part of this is y equals 2, which is right here. So those 3 pieces of information define a bounded region. It's right here. So I'm going to stop there for a second and see if anybody's got any questions. So there'll be 1 or 2 like this where you got to kind of figure out the region. All right. And then it says we're going to rotate this around the x-axis. But it doesn't, it says washer method too, by the way. So washer method means we're going like this. But before we start, there's something we need to figure out. What's missing from that picture? Something missing yet that we're going to need. There's a number missing. What number is missing?
The x value for where they intersect.
Yep, we need to figure out, we need to figure out what that is. We're going to be integrating from the beginning of the region over to here. Well, this number is where these 2 things come together. This is the function y equals 2, and this is our function. So we do 4 minus x squared over 4 is equal to the other function, which is 2. So bring this over. This says x squared over 4 is equal to 2. So x squared is equal to 8. So x is equal to plus or minus the square root of 8. But we're only on this side over here. So we only need the positive one. So we have the square root of 8. So those are the boundaries. So this point right here has the coordinate square root of 8, 2. That's what that point is. All right. All right. I'm going to switch over to the other board for a minute because this one, I'm having trouble writing on here. I think it's dirty. So I'll switch over. All right, so we are swinging around the x-axis. This rectangle goes around and it makes a washer. It's vertical, so we're working dx. So we have a big radius and a little radius. This is the empty space that belongs to the washer. So this is always 2 units high over here. So little r is equal to 2. And the big radius, from here to the top of this rectangle, the big radius is going to be the function minus the empty space. So that's the big radius. I'll pause there for a second in case you got a question. I'll be back and just think about it. I'll be back in just a second. I have to open the front door. Suddenly it got really hot in here. Whoops. Hang on. Be right back. So the apartment I live in is on the second floor of a commercial building, and it soaks up the sun all day on a day like this. And right about this time of night, all that heat comes pouring out. So it's pretty hot up here. I forgot what I was going to say. Oh, so we okay so far?
Can you explain how you got the big R again?
Yep. Let me write that a little bit more neatly. So let's put this guy right down here, little green man, all right? So above him, this is the bottom of this rectangle, and that's always going to be too high. So you're okay with little r?
Yeah.
Okay. The top of the rectangle, the farthest from him, the top of that rectangle is the function, right? So as the rectangle moves back and forth, the top is going to get higher and it's going to get smaller, and the bottom is always going to stay at 2. Is that thinking good?
Yeah, I figured out where you got the -2 now.
Yep. And so I want the height not from the x-axis to here. I want just the height of the rectangle. So I have to literally, this is the empty space of the washer, so we have to subtract that out. So the top of the rectangle is the function. So big R is the function. And then we have to remove the empty space, which was the 2.
Got it. Thank you.
Yep. So it comes and goes, right? Like there's a few minutes where you totally get it and think, oh, this is really easy. And then 2 seconds later, it's gone, right? That's pretty normal, by the way. So don't let that throw your confidence. If understanding comes and goes and comes and goes, that's just how life works. All right. Now we go into the formula. So we're spinning something around and it's not shell, so it's just pi. So our formula will be pi from 0 to the square root of 8. And don't let the square root of 8 throw you. It's just a number that we deal with later. And the formula is big R squared minus little r squared. So we're going to get 2 minus x squared over 4. Now the 2 comes from the function has a 4 in it, and then we subtracted 2. Everybody comfortable with where that 2 came from? I know I kind of erased it, I'm sorry. So we had big R was 4 minus x squared over 4, and then we subtracted the 2. So 4 minus 2 is 2. This is one of the disadvantages of doing this remotely. If we were in a classroom, we would be in the we would be in the first floor of the instructional building. For those of you who know it, I would have a 60-foot whiteboard up in front of you, and I wouldn't have to erase anything. So been an adjustment to do this kind of stuff. And that all has to be squared minus little r squared, which was 2. So that's the setup for the integral. I'll just pause there for a second. I will take silence to mean everybody's okay so far. All right, now we got to do some algebra. Well, I have to do some algebra. You're going to watch. So I have to multiply all this out. All right. When we square this, 2 times 2 is, 2 times 2 is 4. Then we get minus a half. Then we get minus x squared. Then we get positive x to the 4th over 16. And then we get minus 4. And I'm 95% sure I did that correctly. 95%. I'm pretty sure that's the one. I'm pretty sure that's the one. 2 times this is a half, you get 2 of them 1. Yes, so this is good. Now, I could integrate it just like this, but I could make it easier. What cancels out here? Something cancels out. 4. Yep. Positive 4 and negative 4, they just go away. And that's what we're left with to integrate. All right, now we do the only calculus in this problem, which is 1 line long. So we're going to integrate now. Here's the pi. The integral of negative x squared is negative 1/3 x cubed. You could also write that as x cubed over 3. It's fine, whatever you want to do. We integrate this, the integral of x to the 4th gives us x to the 5th. We divide by the new exponent, but there's a 16 down there. So we get an 80 down here. And we're going from 0 to the square root of 8. That's the integral. What's left is to throw the numbers in. Here's a case where 0 is going to give us a 0 because everybody's an x up there. And final answer will look like this. Negative 1/3 square root of 8 to the 3rd power plus square root of 8 to the 5th power all over 80. And when you put 0 in, you get 0. And that answer's fine just like that. The square root of 8 is not a nice number, so anything else you'd use a calculator for would just be approximation. And that's the answer to number 4. Any questions?
How did that 4 and negative 4 cross out?
Like that.
Sorry, I meant 4 minus x squared over 4. What was done to that function to make it so that it was able to cross out when it got squared?
4. Wait a minute. So I'm going back to something, right?
Yeah, I'm sorry. This was before my brain just like went, because I'm looking at like how I did it and I'm like, wait a minute, what changed? And I'm like, oh, that's what changed.
Yeah, no, don't be sorry ever about asking a question. So where do you want me to start at?
just where the big R is equal to 4 minus x squared over 4. I'll let you know just the integral setup.
So that's big R right there.
Mhm.
So 4 minus 2.
Oh wait, there was a minus 2 in there?
Yeah, so
Oh, I
yeah,
missed it.
that's the part you're missing. The rectangle here, big R, the big radius goes from here up to here. So the top of the rectangle is touching, the top of the rectangle is touching the function, right? But we need to account for this empty space. So I have to pull that away. And this is empty space, so we have to subtract it.
Don't they both get squared?
Well, yeah, but I'm just right here. I'm just doing big R right now. So that's the big radius. The little radius is the radius of the hole, and that's just 2 all along here. So now I forgot who asked this question. Was it John?
Oh, it was me, sorry.
Oh, it was John P. So does that answer your question? Almost, or we're not there yet, but you good so far?
I'm just confused why negative 2 was subtracted in the big R.
Because we have to take out the hole in the middle. We have a washer, right? The outside of the washer is the top of the rectangle.
Mm-hmm.
The inside of the washer is this hole, so we have to subtract it out of the disc to have a hole.
Wait a minute. I think I see what you're getting at.
Right?
Mm-hmm.
So if we have this washer, let me draw it this way. So here's this washer. Here's the x-axis. Little r is the radius of the hole. This is the empty space, and that's always a distance of 2 because it's parallel.
Mm-hmm.
So I want the height of the rectangle itself, and it's missing all of this.
Mm-hmm.
So the top of this rectangle is the function, but then we have to literally take away the 2 from the hole. That help?
Yeah, I see what you're saying now.
Yep. So 4, and then this minus 2 and this 4, and that's where big R became 2 minus x squared over 4. So
Right.
big R that's big R.
Mm-hmm.
And that goes into the function. So we have to do big R squared.
You now I see where you got that number from.
So we have to FOIL. So yeah, and then we get the whatever I got on the other.
Yeah. All right, thank you.
Yeah, good. No, see, that was a really good question. All right.
Could we follow through with this one real quick?
Can we do what?
Could we follow through with the rest of it? Or a couple more steps?
Boiling part? Yeah. Like that. So 2 times 2 is 4. 2 times a fourth is a half. 2 times a fourth is a half. So we get negative x squared. And negative x squared over 4 times negative x squared over 4 gives me positive 4 times 4 is 16. X squared is x to the 4th. So that's where that part came.
Okay, and then the small r squared, would that just be 4?
Yeah, 4.
Or disappear? Okay.
And a message from Kayla here. It turns out that comes out to be negative.
Yeah, that's what I got too.
So the problem comes out to be negative? Well, that's, well, that can't happen. I don't think I made any mistakes anywhere. Oh, so little r squared is 2 squared, right? So that's 4. And so that would be minus 4 over here. And that's where these cancel out. And we're left with this integral. And it comes out to be negative? Oh, never mind. Kayla sent me a little private message here. It looks like negative 132, but she's got a wiggly thing in front of it, meaning about. So the final answer is about 133 something when you do it all out. Thanks, Kayla. So, but Michaela, you got a negative number?
Yeah, like I just plugged into my calculator. Like, remember how we got like x to the 5th over 80 minus x cubed over 3?
Uh-huh.
And then it was like on the interval. When I plugged in like square root 8, I got a negative 56 rad 2 over 15.
It could be the way you're punching it into the calculator. So you got to be really careful with parentheses when you do it. So what was my final answer? Let me see if I can remember this. So the final answer was what?
It was pi, and then it was x to the 5th over 80.
No. I mean, so we got square root of 8 to the 5th over 80, right?
Yeah.
And there was a plus or a minus in front of that.
It was plus, and then it was negative 8 cubed, or square root 8 cubed over 3.
Okay. And the 0 doesn't matter there. So that's negative 1/3 times 8 to the 3/2 power plus 1 over 80 times 8 to the 5/2 power. So that's another way to write that final answer. And let's see, so square root of 8 and 3 shouldn't come out to be negative. So Kayla got a positive answer of about 133, and you got negative 50 something.
Yeah, I could try plugging it in again and see if I maybe.
Yeah, you got to be real careful with parentheses here. In fact, you know what? If you switch this around and put the negative in the middle, do you know what I mean?
Yeah, I got the same answer again. I don't know why.
So if you do it this way, if you bury the negative sign in the middle, they're less trouble that way often. But yeah, I don't know. Well, so there's a calculator thing here, which it does not really that important to me in this class. For you engineers, it's important and all that. If you were to do this problem and you got all the way down to this, you're good. If you tried to like simplify it with a so you can leave the answer just like this for me. But if you were to try and simplify that with a calculator and something went wrong, I would notice it. I might say something, but I probably wouldn't even take anything off for that.
Okay, thank you.
Yeah, so sort of the point of chapter 7 is it's not coming up with the answer. It's the process of how you get there. That's the important part to me, if that makes any sense. But thanks for checking that.
Yeah, no problem.
All right. What else we got? Boy, it'll be nice to be doing something different on Thursday. But you got, well, you might not think so when we get started, but at least it'll be different. What else? Anything from the review sheet, other homework or something? So you got area between curves, you got disk washer shell, arc length, surface area. Those are the only topics we've done. We'll get this out of the way and we'll start doing some other stuff. So nobody's got any other questions? Can we do 7? Nicholas, sure we can. Well, I can. I don't know if we can. But you will after I get done with this. Oh, sure. Let's do number 7. You'll see something like this on the test. Like I'll give you one particular region and just have you rotating it a few different ways. It just works out better that way. All right, so number 7. All right, so before we start, That's what the graph of 1 over x looks like. This is what the graph of 1 over x squared looks like. All the negative, because you're squaring it, all the negatives becomes positive and it flips up to here. So that's the graph of 1 over x squared. What does the 10 on the top do to that function? That's 1 over x squared. Here's the x, here's the y. If I change that 1 to a 10, what does that do to the shape of the function? Well, it makes it grow 10 times faster, right? So this is a 1 on top. If you multiply by 10, the y values get bigger 10 times faster. So if you put a 10 on here, it looks like this. It just looks very much tighter like that. It tightens it up. So this is our function. And on number 7, we are going from 1 to 5. So our function is this little shape right there. And I'm going to draw it over here a little nicer. So there's the x values and the y values. So it's that shape right there. And this problem has us spinning it 3 different ways. So part A is so we're going to spin this around the x-axis. It's going to look like a lampshade, like that other problem that we did. So what's the best method to use here? Best method would be, yep, disk. So if we do disk method, the radius is the function itself, because bottom of the rectangle is on the x-axis and the top is touching that curve. So our answer will be pi from 1 to 5 of 10 over x squared dx. That gives us pi from 1 to 5 of 100 over x to the 4th dx. So that's the integral. I'm going to make this a little better. 100 is just a constant, so I can just pull that out. And 1 over x to the 4th can be written as x to the minus 4 dx. So that's the integral that we're going to do. As soon as I wait in case anybody's got a question. That doesn't look so bad, does it? All right. To integrate, we add 1 to the exponent. Negative 4 plus 1 is negative 3. And we divide by the new exponent. And then we go from 1 to 5. Top goes in first. That gives us negative 1/3, 5 to the negative 3 power, minus negative 1/3. We put the 1 in here. 1 to the negative 3 is just 1, so I'm just going to leave it like that. 5 to the third power is 125, but it's negative 3 power, so the 125 goes in the denominator, and there's already a 3 there, so that gives me negative 1 over 375, and minus is plus. And whatever that comes out to, that's the answer. And it's definitely going to be positive because this, oh, wait a minute, no, different, 1 over 375 is very close to 0. So this answer is going to be approximately 100 over 3, and it would be units cubed. So that's part A. Okay with that? All right, part B. Same drawing, same parameters, all the same information. Part B is we're going around the y-axis. All right, spinning it around the y-axis. Of the 3 methods, dishwasher, shell, which ones can we use, which ones can't we use, in case I were to ask you a question like that, which I probably will. What method can't we use?
Disk.
You can't, that's right, we can't use disk because there's a gap. We're spinning the y-axis and we got empty space there, so disk is out. We can use washer and we can use shell. Washer would be harder because you'd have to break this up into 2 pieces over here. Generally speaking, it's almost always true. If you can do shell method, that's the one to go for. The annoying, awful arithmetic is generally easier. So we're going to do shell on here. We're spinning a vertical line, so the shell is also vertical. Since we're spinning the y-axis, rho is just x. And the height of the rectangle is just a function. Shell almost always easiest to use. So shell is 2 pi. We're going from 1 to 5. It's rho times x, so we get 10 over x dx. Rho times x just gives me 10 over x. 10 is a constant. I'm going to pull that out in front. 1 to 5, doing 1 over x dx. And there's the integral. So what's the integral of 1 over x?
ln x.
ln x is correct. That's a Calc 1 thing that goes way back. So our integral becomes 20 pi, the ln of x from 1 to 5. 5 goes in first. We get 20 pi. So ln of 5, and the 1 minus the ln of 1. And that all gives us 20 pi ln of 5. Because the ln of 1 is equal to 0. So that's the answer right there. 20 pi times the ln of 5. Okay. All right. And the last part, part C, we're going around the line y equals 10. We're going around here. So what's the method that we're going to use? This rectangle is going to go swinging around this way. And we've got an empty space here, so we're going to use washer. Because we got this empty space right here. So big R. From the line we're spinning, now this part right here, that's the top of the rectangle when you're standing up here. So from the red line to the x-axis is 5. That's big R. Little radius, the radius of the whole of that washer, is this dotted line. So little r is 5, and then take away the function. That's little r. This distance is 5. This distance is the function. So if you take that away, you're left with that little dotted line, which is the radius of the whole of the washer.
Isn't it 10?
Why would it be 5?
Oh, sorry, 10. Thank you. I don't know, I was looking at this number for some reason. Thanks for the 10. Yeah, it's 10. It's right there, 10, sorry. I don't know why I said 5. I think I just saw that one. Okay. Now we go to the formula. So the formula is pi. We're working dx because it's a vertical rectangle, so 1 to 5. It's big R squared minus little r squared. So that becomes 10 squared minus 10 minus 10 over x squared squared dx. And there's the setup. I don't know why I said 5. Also losing my voice. Okay, algebra. 10 squared is 100 minus, watch out for the negative sign. I have to FOIL this out. So we're going to get 100. Then we're going to get 100. So minus 200 over x squared. This times this will be plus 100 over x to the 4th dx. So FOIL this out and you get this. I'm pretty sure I did that correctly. Oops. Mistake right here. There we go. 10 squared, 100. FOIL this out. Now, this is 100 minus 100, so that's gone. And then minus minus is positive. Minus positive is negative. And we are at dx. So it's looking like not such a bad thing after all. All right. Now I'm going to rewrite it just once more. I can rewrite this as 200x to the minus 2, and I can rewrite this as 100 times x to the minus 4. And that makes it a little bit easier to integrate. Now we do the integral. Add 1 to the exponent, so we get minus 200 x to the minus 1. And over here, we get x to the minus 3 plus 100 over 3. And we're going from 1 to 5. So you integrate, hundreds a constant, just stays there. Add 1, that's negative 3, and then divide by negative 3, which changes that to a plus. Add 1 here, you get -1. Divide by -1, you get -200. And then you just plug those numbers in. I'm not going to bother with that right now. You just put the 5 and the 1 in there. That's not all that important right now. So that is number 7, part A, B, and C. All
I got
right.
a question on finding the big R and small R.
Go
Why
ahead.
why wouldn't the small R be 10 minus? Oh, the small R is 10. Okay.
Because, yeah, I accidentally wrote 5 a little while ago. The little r is 10 minus the function. Yes. And that's where all this other stuff came from. All right. Anything else?
I was doing 4 again with the 2 minus x squared over 4 as my big R, and I also got a negative number.
Really?
I plugged it into my calculator to figure it out. So I plugged in the derivative, which would be 2 minus x squared over 4 squared minus 2 squared. And I noticed, oh, sorry.
The derivative?
The without integrating it. I just plugged it in before I integrated it.
I'm not sure why you would do the derivative.
It just it
The
showed up.
The derivative of y would be negative x over 2.
Oh no, I didn't plug in the derivative. I just didn't integrate it.
Oh, okay.
I just plugged in that function. I realized that it was negative at all points in the domain.
Negative at all points in the domain. Well, the domain of that function is anything you want. Now, any value of x can go into that. That function is a downward polynomials. So that function is a polynomial. Their domains are always everywhere.
I think you should have multiplied by 2. Yeah, you only did the one side. Like it's supposed to be the whole thing.
But the problem only says one side. It's cut off by x equals 0, which is the y-axis.
Sorry, that sounds stupid.
No,
What I meant was that like when I plugged it in, I would just wanted to look at the function. I realized that from 0 to 2 to the square root of 2, it looked like all the points were negative. So it looked like you had a negative volume that you were evaluating. Because Blue Man, I think from 0 would see it as the top as 4.
well, here's the line y equals 2 right there, right? So here's the y-axis. So here's the y. So y equals 2 is this, but that function, when x is 0, you're up here. So the parabola is on the top here. So this is the correct shape. So I'm not sure why. That's 2 people with a negative number and 1 person with a positive number.
It's
I
just,
think I'm getting a negative number as well.
I think that when Blue Man looked up, right, the outer edge was 4 minus x squared. Because
So
the -2 in the big R made it so that it kind of was a combination between rotating it around the 2 and the...
So big R. So here's Blue Man, but he's in black and white tonight. So the top of that rectangle is that function, right?
Right.
Down here. So looking up, so Blue Man is just the line that's spinning, right?
Mhm.
So he's looking up. The top of that rectangle from him is the function itself. It's the curve, right?
Mhm.
And then little r is to the bottom of that rectangle, and that's just 2.
That's what I got the first time.
Right. So those are the 2 radiuses with radiuses.
Yeah, I think the first time it was like 4 minus x squared
But
over
you
4
subtracted
minus 2
2.
for big R.
Subtracted 2 the first time.
Oh, why did I subtract 2?
Because you're like the space in between, you got to take it away. Like for the washer method.
Oh, so so I put a -2 here?
Yeah.
Oh, you know what? I was probably thinking about, I think I was thinking partly about another problem that looked like this. Yeah, so that's my fault. I messed it up. So these would be the correct radius here.
I think earlier you were doing like big R minus little r, that whole thing squared instead of big R squared minus little r squared.
Oh, and now you speak up.
No, I tried telling you before. That's what I wrote in the chat.
Oh, I see. Well, so Kayla sent me the mistake, but that's really tiny font. Yeah, so this is the correct way to have done that problem. I was thinking about some other problem, I guess, or something like that. Sorry about that. We're good. I won't put anything like that on the test. How's that?
Sounds good.
Yeah, won't do that. Yeah, I think I did that this morning too. I did a problem this morning that was just like this, sort of. And I messed that one up because I was thinking about this problem. So yeah, sorry. You won't see that on the test. All right. What else we got? Got just a few more minutes here. Anything else? All right. Well, so like I said, I will be emailing the test to you tomorrow, sometime around the middle of the day. I'm not going to upload it to Canvas, so it's just going to go to you as an email. I'm sending it as a Word document, like the one you're looking at. I'm also going to make a PDF version of it because I've been hearing from some people, they have trouble sometimes seeing the equations on a Word document. In the test instructions will be everything, where to email, how to email, and when the due date is. And then there we go. So we good?
Wait, so you're sending it out when?
Tomorrow in the middle of the day sometime. And you will have 24 hours to turn it around. So from the middle of the day tomorrow to the middle of the day on Thursday, that's when it will be due.
How many questions on it?
I don't know, 9 maybe, something like that. I haven't written it yet. I don't write my tests until the very last minute. If I write them ahead of time, they become impossible because I think, oh, this would be really fun if we do this. So I've learned to just like do them at the last minute. So all the questions will be very similar to all the questions. I mean, we've just been doing the same sorts of questions over and over. So everything should look familiar. Okay. Sometimes I use the even ones from the textbook. Sometimes I put examples in the textbook from the section as a test question. So go through the book and look at all that stuff. All right, we all good? Okay, I will see you all on Thursday when we'll start chapter 8.
All right, have a good one.
Bye, thank you.
Bye.